Chapter 4. Fundamental Research Must Be Given Preference. Let us never forget that the cultivation of the earth is the most important labor of man. Unstable is the future of a country which has lost its taste for agriculture. If there is one lesson of history that is unmistakable, it is that material strength lies very near the soil. Daniel Webster. Many of us are concerned about whether our grandchildren will eat. With proper planning and research, they will not go hungry, but we will have to reorganize our present thinking about crop production if we are to be assured of it. This is a serious question which concerns all of us, especially those who have responsibility of directing the research programs which must be initiated to provide more food for the future. In discussing the problem, we cannot be provincial. We must consider it in terms of our world resources. We still have agricultural frontiers with tremendous potentials for increasing our food supplies. Without delving too deeply into ways and means of growing more food, we probably should consider the means by which we can equitably distribute our food stocks. At the present time, we have surpluses in isolated areas, while at the same time, people in other areas are going hungry. This is a problem at which our politicians are nibbling. Until they decide whether it is more important to feed empty mouths or play at politics, there isn't much that can be done. Fundamental research and politics won't mix under present scheme of operation. So, whether my grandchildren will have enough to eat will depend largely on how we approach the problem of providing food for future generations. I am sure we have the land. We have natural resources. But do we have the brains to know what to do with these natural potentialities? Can we control our rainfall? Can we control floods? They are all related. How well can we combine our efforts to assure ourselves as a world people of a supply of food for 2,000 years hence? The problem. When we begin to speculate on our future food supply and the increase in the number of mouths we will have to feed, we are bound to think about all the possible improvements that may be made. What are the avenues of research through which we can expect to increase our acre yield? I shall list them and discuss them in turn as they appear to me. 1. Extending our frontiers into new land areas still offers possibilities, even though some people seem to think that there are no additional land areas. They assume that when yields reach a low level, it costs too much to bring the soil back to worthwhile production. We are far from having exploited all arable land. Without further research, perhaps we have exhausted our good fertile land, but with more fundamental research we can do much to bring submarginal land within the limits of good land. Of course, we do have much worldwide opportunity to expand. 2. Water supply offers some expansion. Distribution of rainfall is extremely important. We may not know how to change that, but what we do with the rain that falls is of far greater importance. There are many areas that at the present time where most of the rainfall runs off the land. As long as we have property-destroying floods, we are very poor managers of the rainfall we get. We not only wash away much of our topsoil, but we lose many tons of plant food and lime, which we must replace at high prices. 3. Dry weather and water supply. In some areas, one encounters both. Then there are areas where dry weather predominates through the whole growing season, but which have considerable rainfall during the off-season. Holding that water in our soil is worth considering. We also have areas that have little or no rainfall, where irrigation is a must. In the first two cases, we can do something without resorting to irrigation. 4. Commercial fertilizers have far less effect than most of us believe. We need much open-minded fundamental research, which must be integrated with our liming program. 5. Temperature extremes have a controlling effect on acre yields. There is again a very involved question as to what we can do about it, but plant breeding offers much in this field. 6. Sunshine is an all-important factor in our crop yields. Most people say, sure, it's important, but What can be done about it? Well, we don't do much about the weather, but our understanding of its importance can do much to help us modify other factors, such as the use of nitrogenous fertilizers. This field has been very much neglected. 7. Soil types, conditions, and elevations offer big opportunities for research and have potentialities for greatly increasing our world food supply. 8. Crop rotations may be a misnomer. Do they accomplish what most of us think they do? In many cases, incidental to other practices, we have decided that we need more in our soils. 9. Organic matter in soils may have good or bad effects on crop yields. Extensive root growth increases organic matter. We know too little about subjects 8 and 9. 10. Can we agree on what is a productive soil, or are we confusing fertility with productivity? A highly fertile soil may not be a productive soil. What standards have we to judge yielding power? Too many people have the idea that in order to make a soil fertile, we must add manure and fertilizer. We must qualify our statements because a mistake here can be very costly. 11. Limestone makes soil fertile. We have neglected our most important resource. We have a potential of 1 billion tons of food yearly if we learn how to make the best use of limestone. 12. Cultural practices can change yields. Subsoiling can promote bigger root systems. We must learn to farm many feet of subsoil instead of just the plowed layer. The proper integration of all these factors, with all of them exerting a beneficial effect, can result in large yields per acre. Each particular soil type has a certain yield potential. We cannot expect the same yield on different types, even when all of our factors are exerting a favorable influence. And of course, it would be expecting a great deal to expect the same influences to affect the crop in central Illinois that are affecting the crops in central Ohio, partly because weather and soil minerals will differ. We will not underestimate the varietal effect. I helped conduct a variety test in Virginia involving 72 varieties of corn, and the yield varied from 65 to 212 bushels. After 3 years, the 10 highest yields were distributed among practically the same varieties, but the varieties did not yield in the same order when they were grown in 5 different areas in the state. It is necessary to run these comparisons in each corn area to get the largest yielding variety for that area. It becomes a farmer's individual problem. However, from my own experience, I would say that if a person can't grow 100 bushels of corn without fertilizer, he had better investigate the management of his crop. Having sufficient calcium in the soil will practically guarantee the grower over 100 bushels, unless he does something radically wrong, like plowing the ground too wet or working it before the subsoil or A2 horizon has dried out sufficiently so that it can be worked without puddling the clay. Too many of our investigators have the mistaken idea that fertilizer alone will assure the grower good yields. That is the reason why our average yields are so low and have not increased materially since scientific agriculture was initiated. Through my work in agriculture research institutions, I became aware of the shortcomings of our research staffs. Many of these people are in the wrong profession to do society much good. Progress in research comes from original ideas. Very few men are capable of developing ideas. To accomplish something new is a gift from the gods. It would be considered fundamental research. The next step would be to prove or disprove a new idea. For everyone who has a new idea, there are too few who are capable of proving it. In other words, a hypothesis means little if nobody can prove it. A hypothesis is born in the mind of a gifted person. How long it takes to formulate the theory and prove it depends on the intelligence of people who work with it. Thus, one man can start research that will keep thousands of people busy for a lifetime. When I first started in research work on crop production, I was convinced that our soils were woefully deficient in lime. Most of our soil calcium was solidified in tremendous layers where it was unavailable to our crops. I used the soil acidity tester for a number of years, but too often I was disappointed because I could not get better correlations between pH values and yields. I could get increases of 10 to 20%, but some farmers, by their unorthodox methods, did a better job than I could do. I next turned to soil tests as a supplement to the pH tester, hoping to find the key to higher yields. I found out that many of our soils that have been heavily fertilized have a neutral pH but no available calcium. I published my findings in Soil Science in 1928, laying much of the blame for the high pH on the use of large quantities of sodium and potassium salts. Even though this had already been mentioned in the Russian literature, my paper was not well received by American craftspeople. My colleagues criticized my audacity in finding fault with the soil acidity tester. The people who were selling nitrate of soda and muriate of potash were very unsympathetic. I did not find fault with the acidity tester. There was nothing wrong with it. The fault was in the way it was used and the interpretation we placed on the readings. We were trying to test for something which could not be tested by such a method. However, I soon found that testing for calcium paid off. Where 2 or more tons of limestone had been applied to a neutral soil having no available calcium, I increased yields 100% or more. Now, some 20 years later, I still have arguments with agronomists hired by taxpayers as to the validity of the acidity test, and instead of bestirring themselves to initiate research and find out for themselves, they prefer to sit back in a swivel chair and say it isn't possible. The use of high-analysis fertilizers was an episode in my career which still rankles in my mind and for which few agronomists have an answer. With the introduction of 1530-15 fertilizer in the late 20s, there was much speculation as to its value, even though the reduced freight rate could be a factor in shipping at long distance, that is. I compared several of these with our standard 510-5, 587, and similar grades on a unit-for-unit basis. The results were not good for the 1326-13 and 1530-15, and I assumed there was a reason why yields were lower with these high-analysis materials. I compared a no-fertilizer control with my mixture and was surprised to find that the 510-5 decreased the yield slightly, and the 1326-13 decreased the yield even more. These experiments ruined my complacency about the use of mixed fertilizers. I became bitterly critical and never published any results on fertilizer quantity experiments because I never had results showing any particular benefit from the use of mixed fertilizers. In later years, I did publish results on fertilizer placement studies because I seemed to be working in the direction of better fertilizer utilization until I found that the better results I had with plowed-under applications were due to the fact that I had eliminated the root and seed injury where the fertilizer was applied in the row. I continued working with high-analysis mixtures because I wanted to find out why some farmers burned their crops with these fertilizers while others had excellent results. A 13-26-13 mixture was highly soluble and contained only ammonia, phosphoric acid, and potassium. A 5-10-15, slowly available, contained both nitrate and ammonia nitrogen, phosphoric acid as monocalcium, and dicalcium phosphate, muriate of potash, and traces of minor elements. About this time, I chanced to talk with a greenhouse flower grower who was very happy with 13-26-13. I visited his greenhouse and found that he was fertilizing his plants in benches with what looked like sand. When I asked him what it was, he said it was 13-26-13 mixed with ground limestone. On further questioning, I found he mixed 1 part of 13-26-13 with 10 parts of limestone. His flowers were beautiful. I realized he had the answer to my problem. You needed the calcium for good results. I had underestimated the need for calcium. Also, he was using 13-26-13 much more sparingly than I had thought possible. Most of our results showing spectacular increases in yield have occurred on soils which have been classified as submarginal. It is much more difficult to double the yield on supposedly good land where an abundance of fertility exists. I have planted corn on heavily fertilized land, which the grower admitted would not grow 65 bushels of corn, applied the necessary calcium, and found that my method did not show response until after the third year. Fertilization with nitrogen can account for this, and yet my critics have stated the reason I got worthwhile results was because there was so much fertility in the soil from previous years. This was easily proven to be a false premise. With my program, yields increased in later years as this fertilizer was removed through crop production. Whether a soil needs limestone, and if so, in what quantity, may be discovered through an experiment, such as was carried out in Washington Courthouse, Ohio. I checked a field which could not grow over 65 bushels of corn and would not grow clover or alfalfa. The soil acidity test showed no need for lime, but the calcium test showed a deficiency of calcium equivalent to 7 tons of high calcium limestone. This soil was potentially fertile, but needed many tons of limestone to supply the calcium needed to a depth of 3 feet. Even though the soil acidity reading was satisfactory, it took 8 tons of limestone recommended to increase the yield. Had we not applied more than 6 tons, we could easily have assumed that the soil did not need limestone. Human health may demand calcium. I have received numerous letters from women asking me to give my support against the use of commercial fertilizer for growing vegetables. Of course, if chemical fertilizers are harmful to humans, then they are harmful to animals, and we should not use them. Some people have become imbued with the idea that commercial fertilizers are responsible for malignant diseases and for lowering our general health. If this were true, we should have had a definite increase in the occurrence of malignant diseases since the use of commercial fertilizers first began. I doubt this can be proven. I do believe that the deficiency of available calcium in our soils could contribute materially to undermining the health of humans in this country, not because the fertilizer is there, but because something else which humans need is missing. In other words, we must satisfy the lime requirement of our soils first, then add sufficient plant nutrient materials to prevent deficiencies of phosphorus and potash from occurring. This does not answer the critics who expect us to grow good crops without commercial fertilizer, because we must consider the loss of fertilizer from erosion and leaching, besides what plants remove. Organic gardening people assume that the phosphorus that comes from rocks is different from that which comes from manure. Animals live on grass which is grown with the phosphorus, which, because of weathering, becomes available from the complex minerals in the soil. The only difference is that the minerals used in commercial fertilizers are treated with acid to change the phosphate rock to soluble phosphates. But this is just what weathering in the soil does, only faster. People seem to be afraid of the word acid, and yet every process in the soil, as well as in the growth of the human body and in plants, involves the action of an acid on an alkali at some point between the time the minerals are absorbed into plants and animals and the final end product. Concentrated acids may be very corrosive, but in their diluted forms, they make it possible for humans to exist on this earth. Nitrates in well water. The presence of well water of nitrates above the threshold of toxicity has prompted training men to investigate the possibility that this excessive nitrate is poisonous to animals and humans. In some areas in heavy soil, wells were condemned for drinking water. Veterinarians have attributed the sudden death of animals to this vicious killer. The heavy application of nitrogen to our soils is blamed for this, but I don't believe that the facts can be proven. It is difficult to tell the nitrate from the water. Nobody has any proof that the nitrate wasn't present long before any nitrogenous fertilizer was applied to the soil. Perhaps it always was present but never came to the attention of chemists. The people who recommend commercial fertilizer for crop growing are human and feel just as affectionate toward their children and loved ones as those who condemn the use of it. Besides, because they do not have the scientific facts to back up their recommendations, they know that they can safely eat foods grown with commercial fertilizer. The people who belong to the organic cult may not be trained scientifically and may not have the scientific data to back up their statements. As a result, they are careless with the truth. Scientific facts since the time of Galileo have not met with popular response from the public, even though the welfare of the human race is becoming more and more dependent on scientific discovery. Scientifically trained nutritionists are ferreting out the facts so that we may better understand ways and means of improving our health and welfare. Organic matter has many uses. The question of the importance of organic matter, its function, and its value as a source of plant food are not well understood, even by some of our soil scientists. For this reason, the preference of organic farming over the use of commercial fertilizer can be argued with little fear of contradiction. It fits in more closely with natural phenomena and may be quite true, but to date we still need more proof. We all appreciate that a certain amount of organic matter in the soil is a good thing. It helps to mellow the soil when calcium is present. It supplies some plant food, and it does help to buffer the soil. It all adds up to the better crops, but to say it is the ideal is begging the question. Too much organic matter makes the soil black where poor drainage exists. Under such conditions, it could cause damage to crops because of interference with the oxygen supply. Organic plant food is often considered superior to chemical plant food. On sandy, well-limed soils, organic fertilizer may produce better crops than commercial fertilizer, not because of any superiority, but because of differences in availability. It is not difficult to retard growth with too much salt concentration. This, however, does not mean we should increase organic matter. Better plants have bigger roots and leave more organic matter. Farmers who grow crops to make a living cannot afford to build up organic matter in their soil unless they can be assured of yield increases sufficient to pay the costs. The amount of organic matter is determined by climate and intensity of cultivation. When a heavy crop of green stuff is plowed under, it has very little effect on the organic matter, but it does add a large amount of organic plant food, which the next growing crop soon uses up. Organic matter is built from fibrous material found in the roots. Thus, the more roots that can be grown, the more organic matter will remain in the soil. The minerals and salts in a fertilizer bag are the same as those found in any plant, and are the same as those found in animal bodies. There's no reason for the public to assume that there is anything wrong with them. Phosphorus is combined with calcium, both of which are very essential to good human health. Potassium, tied up with chloride or sulfate, is essential to humans as well as to plants. Nitrogen, either as nitrate or ammonia, when taken into the plant, is soon changed to proteins. The calcium and magnesium comes from limestone, which many of our soils are not well supplied. On this basis, I can see no reason for all the criticism of the use of commercial fertilizer, except in our ways of using them. Too much of many things can be harmful. My only criticism is that we haven't learned how to use it to the best advantage. There are mineral elements which can be applied to the soil or are released in the soil which plants will absorb and store in their tissues and which are toxic to animals and plants in rather low concentrations. However, since they are not included in our fertilizer mixtures, there is no need to be concerned about them. Adequate calcium in the soil will prevent any toxicity that could be associated with the use of mineral elements, and thus the importance of providing sufficient quantities of limestone for our soils takes on more significance. If I were to pick out any one thing of the fertilizer industry which might raise a question in my mind, it would be the application of greater amounts than are actually needed. Most crops don't suffer from a lack of fertilizer so much as they do from an imbalance of nutrient materials.